This is Miss Often, and in this video we'll be doing a quick introduction to coordinate proof. By the end of this video, you should be able to position figures in the coordinate plane for use in coordinate proofs and be able to prove geometric concepts by using coordinate proofs. This will apply both to figures that have numeric coordinates and to figures that have variable coordinates. Let's get started. So previous to this, you've used coordinate geometry to find the midpoint of line segments and distance between 2 points, but coordinate geometry can also be used to prove theorems and conjectures. The first step of a coordinate proof is to position the given figure in the plane. You can use any position you want, but with some strategies, it's going to make the steps of the proof simpler to do. And you want to be sure that you pay attention to what type of figure you have so you can utilize appropriate strategies. So one strategy, you can use the origin as a vertex and keep the figure entirely in quadrant 1. Keep in mind that you are dealing with lengths and angle measures here, so because it's plane geometry, those values should always be positive. You can center the figure at the origin. That can be especially helpful if you're working with midpoints of figures. You can center a side of the figure at the origin. You can use one or both axes as sides of the figure. Okay, if you're using both axes, you want to remember those do make right angles with each other, so you want to be sure that the figure does have a right angle. Now, your tools here are going to be slope, distance formula, and midpoint formula, and you're going to want to use the coordinates of the vertices to prove statements about the given figure. So we're given rectangle ABCD with A at 0, 0, B at 4, 0, C at 4, 10, and D at 0, 10. Here's our figure graphed right here, and we're asked to prove that the diagonals bisect each other. So here's a picture, and it looks like the diagonals bisect each other. Visually inspecting, it looks like the diagonals intersect at 2, 5. We do want to be sure that that is a bisecting point. Now I know that if a segment is bisected, it is bisected at the midpoint. So I want to show that both of these have the same midpoint. So here we go. By the midpoint formula, the midpoint of AC is in fact 2, 5. The midpoint of BD is also 2, 5. Since the midpoints coincide, the diagonals bisect each other. Now this was done with specific numeric coordinates. We can do this same type of proof in a coordinate manner, but more generally by using variables. We'll see that in an upcoming problem. Okay, using this diagram, we want to show that the area of ADB, which is this upper triangle, is 1/2 the area of ABC, which is the full triangle. Remember that the area of a triangle is 1/2 base times height. Here we go. There's the area of the triangle. And we have 4 units times 6 units. That area, therefore, is 12 square units. So we want to show that this other triangle has an area of 6 units. Okay, now we're given that ABC is a right triangle, height AB, and base BC. The coordinates of D are at 2, 3. So keeping in mind that we had this previous triangle, it's 4 by 6, this at 2, 3. Now my height of my triangle, or my base of my triangle, is now 6, but my height, the distance from the vertex to a side along a perpendicular, the altitude of the triangle, is 2. So I can multiply 6 times 2, find half of that, and it's going to be equal to 6 square units. Now, since 6 is half of 12, the area of ADB is 1/2 the area of ABC. Again, if we want to show that a certain relationship is always true, we're going to assign variables as the coordinates of the vertices. And when we do that, we do want to be sure that we follow some of those suggestions that were provided on the earlier slide. Here, we've positioned a rectangle in the coordinate plane. with a width m and a length twice the width. So you can see that here I go from 0, 0 to 0m, and then I went over to 2m. Positioning the figure in the coordinate plane and giving the coordinates of each vertex. I have a right triangle with legs of length s and t. Okay, so looking at this goes from 0 to s, so that is s units long. This I know is t units long, because it's going from 0 to t along the x-axis. And this is a right triangle because my axes are at right angles to each other. Very important, the axes are always at right angles to each other, so you have to only use them if you know the figure has a right angle. Okay, if a coordinate proof requires calculations with fractions, be sure to choose coordinates that make the calculations simpler to do. So multiples of 2, finding coordinates of a midpoint, and we're going to see this distance formula. So you have done this in your prior supplemental problems. So here's a coordinate proof. I want to prove in rectangle PQRS that the diagonals are congruent. Now I know this is a rectangle because it does have 4 right angles. So I want to be able to show that these diagonals have the same length. Okay, so I'm going to walk through the proof of this. Got my coordinates assigned to each vertex. The distance formula from P to R is the square root of a squared plus b squared. See my nice little right triangle here. And similarly, QS has a length a squared b squared. Now, because QS is equal to PR, by the definition of congruent, segment QS is congruent to segment PR. All right, so we're going to write a coordinate proof showing the area of ADB is 1/2 the area of ABC. And we're going to assign coordinates to each vertex. Let's look at our diagram here. We're given that D is the midpoint and ABC is a right triangle with height 2j and base 2n. So again, looking at this, zero, 2j, 2n, comma 0. D is the midpoint of this segment, so it is going to be at n, comma j. Okay, so this area is going to be 1/2 2j times 2n. That's my area of ABC. It is 2nj as shown here. My base and height for triangle ABD, this is 2j, this is n, so hopefully already you are seeing that this is going to be in a 1/2 relationship. So this is just going to be equal to nj. And you can see that choosing those multiples of 2 for the coordinates really helped make everything easy to work with. It made fewer fractions. And again, nj is 1/2 of 2nj. The area of ADB is 1/2 the area of triangle ABC. Okay, so that's it for this video on an introduction to coordinate proof. We'll be using this again in some other units, and I hope you found this useful. Thanks, and have a great day.